Welcome to my video on the science that holds our universe together, physics. Physics is special in that it constitutes all of the laws of nature that keep you, me, and everything around us the way we are. It explains why we don't just fly off the giant spinning ball we call Earth, and it is the reason things move the way they do. We experience physics every day, but in this video, we are going to take a look at some physics behind one of the substances that is necessary to all of life, water. For the first two clips, you will see the comparison between the speed of rain and falling snow. Rain falls due to the acceleration of gravity, the rate at which all objects falling towards Earth gain speed, and because of this, rain falls rather quickly. However, not all things fall at the same rate, even though gravity acts on all things equally, and this is due to air resistance that is keeping various objects from falling at a faster speed. The resistance is caused by the friction between the air and the object. Friction can be understood as the force that acts on a moving object against the direction of its movement. On surfaces, this can be caused by the texture of the surface, but in gas, this is from the gas particles acting against the object. The resistance on an object depends on three aspects of it: its size, shape, and speed. On larger surfaces, there is more area for friction to occur, and in air, this equates to an object traveling at a lower speed. This concept is how many objects are able to glide through the air. In this video of snow, you will notice that the snow travels at a much slower speed than rain. This is due to the structure of snowflakes being a relatively flat surface, as opposed to the smaller surface area of raindrops. Thus, friction, air resistance, acts more heavily on snow than it does on rain, accounting for the slower speed. In this next clip, you will see a demonstration of pressure based on surface area. Pressure may be defined as the physical force that an object exerts on another object per unit of surface area in contact. First, you will see a shovel that is dropped straight down into about a foot of snow. You will notice that the shovel reaches the ground, and this creates a deep gash in the snow. However, I will now show you what happens if you drop the same shovel flat on the snow from the same height. The shovel hits the snow and creates a dip in the snow only a few inches down. When you compare the two, the shovel that was dropped straight down created a much deeper hole, but the force carried by the shovel's weight is the same in both cases. This is due to the fact that pressure of an object is indirectly proportional to the surface area of an object. So, when the shovel is dropped straight down, the surface area is very small, and the pressure on the snow is high, creating the deep gash in the snow. Thus, we see that the force of the shovel can be exerted over a larger area, in turn, creating less pressure on the snow. Here, we will see a demonstration of density, as well as Archimedes' principle. You will probably see this often, but it is an excellent physics example. Ice in a glass of water shows that the density difference causes the ice to float. The density of an object is found by taking the mass of the object and dividing by its volume. Essentially, density is how much of the substance's matter is found within the space it takes up. The lower density of the ice compared to the water causes it to float. Likewise, the ice floats due to Archimedes' principle. This law of physics states that any object submerged partially or completely in a fluid is acted on by an upward force. This force is referred to as the buoyant force, and it is equal to the weight of the fluid displaced by the object. This means that the ice cube is also floating due to the upward force caused by the displacement of water it creates. The same principle is used for all floating objects, especially boats. In the case of boats, the high mass of the ship weighs down on the boat and the displacement of water keeps it afloat. However, if the volume of the mass increases, the boat will float more easily, and the opposite is also true. Less volume to mass, higher density. The boat will sink. In our case, we can see that the ice cube is floating due to its density being lower than that of water, and Archimedes' principle. As for the next video clip, we will see a simple machine at work. A simple machine may be defined as an object that makes doing work easier. For work to be done, an object must move in the direction of an applied force. So, a simple machine can make moving another object easier. Some examples of simple machines are levers, ramps, and pulleys, but the simple machine we will be observing is a wedge. A wedge is an object with a point and two sloping sides. You probably use a wedge almost every day. Knives, scissors, and other objects that cut are considered to be wedges. The way they do work is by cutting between an object and separating two portions of it. This separation or movement of the object being cut is the work that is being done. In our example, we see that an ice skate cuts through the surface of the ice. It cuts the top layer and pushes the ice to either side of the skate. The blade on the skate is our wedge. Finally, we will see a clip of something that we all experience every day of our lives. Thermal energy is everywhere. It is even in our bodies. Heat is defined by the Pearson Conceptual Physics book as the energy that transfers from one object to another because of the temperature difference between them. Heat is an important form of energy, and it is involved in many things: cooking, freezing, and even body temperature regulation. But thermal energy has a tendency to move between objects fairly easily. As we all know this to be true, when we touch something hot, it burns our skin, because heat is transferring to our body, which has a lower temperature than the hot object. Heat always flows from hot to cold in order to reach a common temperature between the objects in contact, and such physical transfer of heat is known as conduction. This can further be defined as the transfer of thermal energy through contact of particles. Conduction may be found in many everyday examples, but for one, putting ice in a hot bowl of soup would not make the ice scalding hot, nor would it make the soup freezing cold. Instead, a temperature is found between the ice and the soup, making for a nice warm meal. This common temperature is called the thermal equilibrium, and this is the temperature that is reached when the hot and cold object meet in the middle. In conclusion, physics is a major part of our everyday lives, and its effects on water help to keep our world and us together. Physics can be found everywhere, and I hope that you will take your new knowledge of water's physics and further learn about how physics keeps our world going.